Hi everybody, in this video I am going to discuss full adder circuit in digital electronics. This is a very important circuit in digital electronics. First point, it is a combination circuit. This is known as combination circuit whose outputs depends on inputs at any instant of time. It is a combination circuit. This is the first point. Second point, it is used to add three single bit binary number, three single bit binary numbers. Third point, it has three inputs. It has three inputs A, B, and C in, carry in, and two outputs. Some S and C out mean carry out. So these are three inputs and A, B, C in and two output, sum and carry out. Next one is block diagram. Next one is block diagram. It consists of, this is the block of the full adder. It consists of three input A, B, and C in, and two outputs sum and carry out, C out. Now the truth table. Next one is truth table. We need to create the truth table. Truth table. Next one is truth table. It consists of three input. Mean input. There are three inputs A, B, and C in, and there are two outputs. One is S, another is carry out, C out. There are three input variable, hence there will be 8 combination of inputs. We need to write 8 row. These are the 8 combination of rows. 0, 1, 2, 3, 4, 5, 6, 7. 0, 1, 0, 1, single 0, single 1, 0, 1, 0, 1. 0, 0, 1, 1, 0, 0, 1, 1. Next, 0, 0, 0, 0 and 1, 1, 1, 1. In this way, we will get the equivalent binary number of 0, equivalent binary number of 1, equivalent binary number of 2, equivalent binary number of 3, 4, 5, 6, and 7. So these are the input combination of the full adder. Now we need to find sum and carry out for the truth table. 0 plus 0, we need to write first of all 0 and 0, then we will get 0 plus 0 means sum 0, and there is no carry, mean sum 0, C out is 0, means sum 0 and C out is also 0. The next one is 0, 0 plus 1. First of all, we need to add A and B, 0 plus 0, then we get 0 and there is no carry, then plus 1, 0 plus 1 is 1 and carry is 0, mean sum 1 carry 0. Next 0, 1, 0. 0 plus 1, the sum is 1, there is no carry. Next 0, 1 plus 0, sum is 1, there is no carry. Sum 1 carry is 0. Next 0, 1, 1. 0 plus 1, that is sum 1, there is no carry. Then 1, we need to add this 1, means sum means 1 plus 1, 0, and there will be a carry, mean 1, 0, 1. Next 1, 0, 0. 1, 0, 1 plus 0 equal to 1, there is no carry. Then next 0, 1 plus 0 equal to 1 and 0, mean 1, 0. Next 1, 0, 1, 0 mean 1 plus 0 equal to 1, there is no carry. The next one, 1 plus 1 is 0 and carry will be 1. 0 plus 1 is 1. That means sum 0 carry 1. It is easy to remember this concept. 1 plus 1, 1 plus 1, that is sum 0, there is a carry. The next one is 0, 0 plus 0 and carries 1, means sum 0, carry 1. For 1, 1, 1, 1 plus 1 is sum 0, carry 1. The next one is added, means sum 1, carry 1, 1 and 1. So in this way, we'll create the truth table for full adder. Remember, if there is only one single input, then output will be sum 1 carry. Remember, if any of the input combination there is single one, sum is always 1, carries Cout is 0. Here there is single one, sum 1 carry 0, single one, sum 1 carry 0. Here single one, sum 1 carry 0. So easy to remember. If both the input combination there are 2 1, the sum is 0 carries 1. This 1 1 sum 0 carry 1. 2 1 sum 0 carry 1. In this way we will get the truth table. Now we need to find the Boolean expression for this. Now we need to find the circuit diagram for full adder. First of all, we need to construct the Boolean expression. Like arithmetic expression in digital electronics, we need to construct Boolean expression. To construct the Boolean expression, we need to create the K-map. K-map means Carnot map. It is used to minimize Boolean expression. K-map for S. There are 3 input combination, so there are 3 cell of the K-map. One is A bar, A. Another is B bar, C bar, B bar, C, B, C, and B, C bar. This is the combination of B and C. This is the value of 0, this is 1, this is the 2, and this is the 3. 4, 5, 6, 7. We need to remember the structure of the K-map for 3 variables 0, 1, 2, 3, 4, 5, 6, 7. Now we need to put the value of S here. In the decimal value of 1, there is a 1. We need to find the mean term. This is sum of product. In second position, there is a 1. Then in the fourth position, there is a 1. Then in seventh position, there is a 1. There is no grouping is possible because they are in diagonal position. So we need to select individual 1. So we need to group only 1 for this K-map. Now we need to construct the Boolean expression from the K-map. A is equal to, here remember C is a, there is no C, so we need to write C in. Here we need to write C in. Now A is equal to this, for this one, A bar, row and column. So we need to take the common value of, we need to take the column value between row and column. This A bar, B bar, C in. A bar, B bar and C in. Then plus. Next for this second position, A bar, B, C in bar. For the fourth position, A, B bar, C in bar. A, B bar, C in bar. Next for the seventh position, A, B, C in. A, B, C in. Now we need to take the now we need to simplify the Boolean expression. Here A bar is common, that's mean B bar C in plus B C in bar. Next one is A, taking A common, B bar C in bar and B C in. This is the Boolean expression for XOR gate, that is B XOR C in. Next plus, and Boolean expression for XNOR, B XNOR C in. We know the XNOR is a complement of XOR. That's mean A bar B XOR C in plus A B XOR C in, then complement of B XOR C in. XNOR is a complement of XOR. Now it is a again combination of XOR, that is A XOR B XOR C. So these are the three XOR combination of A, B and C. Now we need to find the K-map for Cout. Now we need to find the K-map for Cout. K-map for Cout. Here position of the Cout, position of 1 in Cout is, that is 3, there is a 1 in 3 third position, 5th, 6th, 7th. So Cout equal to summation of M 3, 5, 6 and 7. Construct the K-map for this 3, 5, 6, 7. These three variable, there are 3 variables, so there will be 8 combination of values. A bar A, B bar C in bar, B bar C in, B C in and B C in bar. 0, 1, 2, 3, 4, 5, 6 and 7. Now in the third position there is a 1, fifth position there is a 1, in fifth position there is a 1, in sixth position there is a 1 and 7 in 1. Taking group for this 3 and 7, 5 and 7 and 6 and 7. Now for 3 and 7 there is an BC in, column wise BC in is common, next plus for row wise AC in, then for this row wise AB plus AB. So these are the Boolean expression for sum. This one is for sum and this one is for carry out. Now we need to construct the final circuit diagram. So in this way we can create full adder circuit. Now the circuit diagram for sum A, B and C in. So there is an A, B and C in. These are the three inputs. First of all, we need to construct XOR between A and B. This is an XOR gate. And then C in another XOR gate. We will get the sum of S. So this is the output of S. Now we need to construct the Cout expression. A B C in, and this means multiplication of B C in AND gate. We need to use AND gate B and C in. There is an AND gate. When there is a multiplication operation, then we need to create AND gate. This means B C in. Next one is AC in, A and C in. This means AC in. And next one is AB, A and B. These are added together using the OR gate. OR gate is used to add Boolean expression. This means this one is known as Cout. So this is the circuit diagram of full adder. So thank you very much for watching this video. Share and subscribe it. Thank you.